This is an AQA A-level chemistry question, and it's on the topics of amount of substance, but also transition metals. So have a look at each section, try them as you go, and then pause and review your answers. Starting with part A, part B, and finally part C, and it's a total of 11 marks. So if we go back to part A, you can see here that the structure of EDTA has been provided and always will be. It's actually the EDTA 4- ion. We're told it can act as a multidentate ligand. Your first job is to draw a separate circle around each atom that bonds to the Cu+2 ion. So even though you don't need to learn the structure, you do need to be aware of where the lone pairs are that are going to form the coordinate bonds with the central metal ion. And there is a symmetry to them. They are on the ends close to the centre, and they are on the O with a single bond, not the double bond. All of those, and you get 1 mark. We then have to explain the meaning of the term multidentate and ligand, but I want to highlight something really important here. The question says with reference to the reaction of EDTA 4-. That means you can't simply give a generic definition for either of the two terms. So multidentate, for example, we can't just say it's something that forms many coordinate bonds with the central metal ion or cation. We have to say that in this case it's the EDTA 4- that does that. And when we talk about a ligand, we are talking about the lone pair on the EDTA 4- forming a coordinate bond with the copper 2 ions. And we know it's copper 2 because we're starting with the hexa-aqua copper 2 here. Moving on to part B, and we've got copper 2 compounds used as fungicides in vineyards. Copper 2 ions can enter the water supply and cause problems because they're toxic in high concentrations. The water supply for a vineyard can be tested by forming a blue aqueous complex with EDTA 4-. Outline the practical steps that you would follow using colorimetry to determine the concentration of this complex in a sample of water. So the Colourimetry Practical is one that you need to be able to remember the process, remember the method, and also think about why we're taking each step. So, first of all, we're going to produce a calibration curve. To do that, we're going to test the colorimeter with solutions of the copper EDTA complex of known concentrations. So, as an example, you might do 0.1 molar, 0.2 molar, 0.3 molar, etc., and go up incrementally. Add excess EDTA to the sample. That's EDTA 4-. When you have got your calibration curve, what you can then do is take an unknown sample and you can actually plot on the graph to find out what the concentration of it would be. For part C, we've got a 5-mark calculation. Concentration of copper ions given. Result was checked by titrating a sample of water with a solution containing EDTA 4-. If you take the time to read through, and then we will have a look at how we're going to go about answering it. As always, I'm going to recommend that if you are given values, make a note of them and work out what you can work out with what you've been given. First thing here, though, is actually to write the equation out, that when we start with our hexa-aqua copper 2, all 6 water molecules are going to be displaced, replaced by the EDTA 4-. This -2 on the Cu EDTA complex is absolutely vital, because it's 4- on the EDTA and the copper is 2+. From there, we can work out the moles of Cu+2. And you can see where I've taken the data from upstairs, so the colour coding will direct you to where you're finding the information. Once you've got the moles of Cu2+, you can now use the mole ratio from the equation to see that you now know the moles of EDTA. And so if we know the moles and we know its concentration, that's been provided, we can work out the volume. So we take the volume and we get 189 centimetre cubed. You'll notice I've also multiplied, it's actually 1.89. So you will notice that it has been multiplied by 1,000. And that is because we need to convert from decimetre cubed to centimetre cubed. However, it's not very accurate. And so for the fourth mark, we're seeing that that volume is very small. And that means that any difference from that volume would lead to quite a big margin of error. And in a titration, if you think, in the vast majority of cases, it's in the region of 25 cm cubed. It's certainly not going to be only needing to add 1.89. So what could we do? Well, you could dilute the EDTA 4- solution down so that a larger volume is needed. If you multiplied that down by a factor of 10, that would take you to 18.9 centimetres cubed. That takes us to the end of this question. Thank you for listening.